Load the Excel file. We start by loading our dataset from an Excel file into a Pandas data frame. fd pd.read.excel. Accepted 2007 to 2018 Q4. Canlias. This command reads the Excel file and stores it in a variable called fd. Display first few rows. Next, we preview the first few rows of the dataset to understand its structure. Print preview of data and fd head. The head function shows the top rows of our data frame. Summary statistics. We then calculate summary statistics to get an overview of the data distribution.
Info about columns. We also check detailed information about each column in the dataset. fd.info. The info function shows column types, non-null counts, and memory usage for feature in fd columns here. We iterate through all the column names to examine each feature, print feature. Each feature name is printed to help identify variables in our dataset. Miss equals fd isna, closing parenthesis. Sum we calculate the number of missing values in each column. Missing underscore entries underscore sorted equals missed. Sort underscore values ascending equals false. Then we sort the columns by how many missing values they contain. Print missing underscore entries underscore sorted. This helps us quickly identify which columns have the most missing data. Removing columns with too many missing values next. We decide which columns to remove based on missing data thresholds. Lower equals 1,130,351. We set the lower bound of missing values to consider for dropping columns. High equals 2,260,701. We also set the upper bound for this threshold range, 058 to 102 missing underscore num equals fd isnel, closing parenthesis dot sum. We count missing values in all columns again to apply our filter. High equals 2,260,701. We also set the upper bound for this threshold range, missing underscore num equals fd isnel, closing parenthesis sum. We count missing values in all columns again to apply our filter. Features underscore 2 underscore drop equals missing underscore num. Missing underscore num greater than equals lower. And missing underscore num equals high. Index columns with missing values within this range are selected to be removed. FDs equals FD. Drop columns equals features underscore 2 underscore drop. These columns are then dropped from the dataset to clean the data. Print dropped features. Features underscore 2 underscore drop. We print the names of the dropped columns for confirmation. 114 to 117 hash. Dropping rows with excessive missing data now. We remove rows where most values are missing to further clean the dataset. Encoding categorical values next. We encode categorical variables into numerical values for modeling. FD's det underscore settlement underscore flag unique. We examine unique values in the categorical column from SLN. Pre-processing import labelencada. We import labelencada to convert categories into numbers. Label underscore encoder equals label encoder. We initialize the encoder object. FD's label equals label underscore ENCODER dot fit underscore transform FD's det underscore settlement underscore flag. We transform the categorical column into numeric labels and store it in a new column label, setting up LIGHTGBM. Now we prepare the dataset for LightGBM, ensuring all categorical variables are numeric. Import LightGMA. As LGB, we import the LightGBM library for gradient boosting modeling from Sclaren metrics import accuracy underscore score classification underscore report. Confusion underscore matrix, we import metrics to evaluate our model later. Categorical underscore columns equals DF. Select underscore D types include equals object columns. Tolist we identify all remaining categorical columns in the dataset for col in categorical underscore columns. We iterate through each categorical column df col equals lfit underscore transform. Df col, each column is transformed into numeric values for the model. 236 to 240 hash. Splitting and training LightGBM model next, we split the data and train the LightGBM classifier at print accuracy. Accuracy, we display the model's accuracy. Print classification underscore report y underscore test. Y underscore pred. We print the detailed classification report including precision, recall, and F1 score. Print confusion underscore matrix y underscore test. Y underscore pred, we display the confusion matrix to see correct and incorrect predictions. Checking feature importance next, we examine which features are most important in predicting the target. Importance underscore DF equals PD data frame feature x dot columns. Importance, we create a data frame showing each feature's importance. Model.fit_x underscore train. Y underscore train. We train the model on the training data. Y underscore pred equals model. Predict x underscore test. The trained model predicts outcomes for the test set. Evaluating the model now, we evaluate the model's performance using accuracy and classification metrics. Accuracy equals accuracy underscore score y underscore test. Y underscore pred. We calculate the accuracy score of the model. Print accuracy. Accuracy, we display the model's accuracy. 308 to 312 print classification underscore report y underscore test. Y underscore pred. We print the detailed classification report, including precision, recall, and F1 score. At majority underscore class equals filtered underscore DF, filtered underscore DF label equals 0. We separate the majority class samples. Minority underscore class equals filtered underscore DF, filtered underscore DF label equals 1. We separate the minority class samples. Balanced underscore DF equals PD concat. We oversample the minority class to match the majority class, then shuffle the dataset. Train validation test split. We split the data into training, validation, and testing sets for evaluation. x underscore train, x underscore val, x underscore test equals. This ensures proper model evaluation across different datasets, filtering and filling missing values. Now we keep only important features and handle missing numeric values. For column in columns underscore 2 underscore fill, we iterate through selected columns filtered underscore df column, fillna filtered underscore df column. Mean in place equals true missing values are replaced with the mean of the column. Filtered underscore df drupna in place equals true. Any remaining incomplete rows are dropped to clean the dataset fully. Balancing the dataset, we balance the dataset to prevent bias by oversampling the minority class. Majority underscore class equals filtered underscore df filtered underscore df label equals 0. We separate the majority class samples. Minority underscore class equals filtered underscore df filtered underscore df label equals 1. We separate the minority class samples. Balanced underscore df equals pd concat. We oversample the minority class to match the majority class, then shuffle the dataset. Train validation test split. We split the data into training, validation, and testing sets for evaluation. X underscore train, X underscore val, X underscore test equals. This ensures proper model evaluation across different datasets. 411 to 415 hash. Feature scaling. We scale numeric features to standardize the data range. At LG underscore predictions equals LG dot predict X underscore test. We generate predictions on the test set. Final evaluation. Finally, we evaluate the logistic regression model on both test and validation datasets. Print logistic regression accuracy. Accuracy underscore score Y underscore test, LG underscore predictions. We display the accuracy of the model on the test set. Print classification underscore report Y underscore test, LG underscore predictions. We show precision, recall, and F1 score for the test set. Print F validation accuracy, accuracy underscore score Y underscore val, Y underscore VAL underscore pred. We display the accuracy on the validation set. 454 to 458 print classification underscore report Y underscore val, Y underscore VAL underscore pred. We show the classification metrics for the validation set. The project is now complete.